Kia ora koutou, Reese from QuickSense here, and today we're looking at algebraic indices. This question or these questions often ask us to manipulate or simplify indices, and indices really just mean powers, but are often expressed in terms of rational expressions, so algebraic fractions. Now in this instance here, the way I'm going to think about it is by unsimplifying it to find common factors that I can cancel out. So I'll show you what I mean. So 8 is equal to, and I'm going to think of it in terms of its prime factors, 2 times 2 times 2. Those are the prime factors of 8. X to the power of 3, let's unsimplify it. That's x times x times x. And then y to the 8 is y 8 times. Obviously, when you're doing it, you don't have to spend this long, but I really want to show you guys what's happening and why it's happening. 4 is 2 times 2, x times x, and then y to the 5 is y 5 times. Okay, now we get to the fun part. We start cancelling things out. 2 divided by 2, well, that's 1. Anything times 1 is the same as it was before. 2 divided by 2. And now I've got 1, 2 left over. Right? So I'm going to leave that 2 up there. Now, x divided by x, x divided by x, and I'm left over with an x on top. Y. Remember, I'm cancelling these out because they equal 1. Then that leaves me with 1, 2, 3 y's on the top. And I've got nothing on the bottom. So I'm just left with this invisible 1. Right? There's always an invisible 1 somewhere. Times by, divide by. And I can simplify that to 2x 3. Now an easier way to think about this is 8 divided by 4 is 2. 3, right? 3 take away 2. 3 take away 2 is 1. And then 8 take away 5 is 3. And there is the expression simplified. In this question here, I'm given a particularly tricky looking expression, and I'm asked to express it in another form. Right? So with these kind of square root or root style form, and the first thing I need to do is remember, what is that equivalent to? So what are some of the indices rules that I have? Well, let's keep it like this, right? N T M is going to be equal to T M over N. Right? A root is the same thing as a fractional indices. Okay, so that's the first law that's important. And then at the top here, right, you can see if I write this down, so t to the negative 5 times the square root of t. Well, I can immediately start simplifying this with respect to the law I have at the top. So t negative 1 over 5 times, well, there's a 1 here and there's a 2 here, right? We just often don't write that. So that becomes 1 over 2. Right, the 1's there and the 2's there. Down on the bottom, t, well, that's 2 over 3, in the same way as we did it on the top. Okay, now my second indices rule, when I'm looking at the top here, I'm multiplying indices with the same base. So if I do that, let's stick with t. So tm times tn is equal to tm plus n. All right. So t negative 1/5 plus 1/2, and we're dividing by this here. Well, what does that become? Well, negative 1/5 take away 1/2. I can simplify that, give it the same denominator, which is going to be 10. So that becomes negative 2 over 10 plus 5 over 10. And that becomes 7. Negative 2 plus 5 is 3. Okay, so now what do I do? Well, now I can think of one of my final indices laws, is that this is equal to T m minus n. Okay, so that becomes T 3/10 minus 2/3. All right, we're just going to do it in a little bracket over here. Common denominator is going to be 30. So 10 times 3 is 30, so that's T 9 over 30. Take away, well, that becomes 20 over 30. 9 take away 20 is negative 11. Don't forget the base. Negative 11 over 30. Now I can't simplify this anymore like this, but the question wants it in terms of this here. So I have to come back. Now I'm moving from this here back to this. So this is equal to 30 root t to the power of 11. And that is the answer.